Okay, so today we're going to solve quadratic and rational inequalities. All right, so just a quick reminder that your inequalities are just your less than, your greater than, your less than or equal to, or your greater than or equal to. Okay. Now for a quadratic equation, that would just be in the form, well, I'll put it right next to it. Ax squared plus bx plus c is less than 0. Ax squared plus bx plus c is greater than 0, or you're less than or equal to of the same ones. Ax squared plus bx plus c is less than or equal to 0. Ax squared, clean that up a little bit, plus bx plus c is greater than or equal to 0. Clean that up just a hair. All right, so now we're going to go over the actual steps for solving inequalities. Try to leave as much of that showing. Okay, so steps for solving. Quadratic inequalities. Okay, so your first step is you're going to solve it in standard form. So solve your inequality in standard form. And by standard form, it's just you're going to solve ax squared plus bx plus c, and instead of one of the inequalities, you're just going to make it equal 0. Okay? And your solutions here would be your critical numbers. So they're called critical numbers. Okay. Bless you. Okay, so your second step is you're going to take those critical numbers and you're going to place them on a number line. So you're going to place your critical numbers on a number line. And normally I do step 2 and 3 at the same time, but I just kind of mark them separately. Clean that up a little bit. And give that a little bit of space. Here we go. Okay, so your third step is you're going to pick test values in between your critical points. And And when you get those test values, you're going to plug them into your original inequality and see if it's true. Uh-oh, test points. So you're going to pick test points. And they're completely random. In between your critical points. And plug into your original inequality. To see if it is true. Okay. So if it's true, then that means that interval is actually a solution. If it's not true, that means that interval is not a solution. And your fourth step is just where you're going to put for your solution interval. If you have less than or greater than in your original equation, then you're going to put parentheses. If you have less than or equal to or greater than or equal to, you're going to put brackets. So place your solution. I guess you can say place your solution or more than one with parentheses. If using less than or greater than, oh, we bring that up a little bit. There we go. Or you're going to place your solution with brackets if you're using less than or equal to or greater than or equal to. Okay. If you have negative infinity or positive infinity, you're always going to use parentheses for those. And let me make a little side note for that. Negative infinity will always use parentheses. Leave that up for a few seconds. Okay, so let's say, for example, let's say if we want to solve x plus 3 times x minus 2 is less than 0. Okay, this one's pretty straightforward because they already factored it for you. For most of them, you're going to have to factor it first. But since this one's already factored, you don't have to really worry about it. Okay, so remember your first step, you're going to solve it in standard form, which means x plus 3 times x minus 2 is equal to 0. Okay, which means that x plus 3 can equal 0, or x minus 2 can equal 0. Okay, if we subtract 3 from both sides, x can equal negative 3, or add 2 to both sides here. X can equal 2. That could be better. There we go. Okay, so we have our 2 solutions, and those are your critical points. Okay, so for your second well, you're going to do those together. For your second step, you're going to put your critical points on a number line. I might as well say second and third steps because we're going to do those together. Okay, so if we have our second step, you're going to have -3 and 2. Okay, so remember your second step is number line. And your third step, you're going to pick test values. Okay, so you're going to pick numbers in between there, which means you can't pick -3 and you can't pick 2. Okay, so this interval here, this is from -infinity all the way to -3. In between here, it's from -3 to 2. And this here goes from 2 to infinity. So that's where you're going to pick your test values from. Okay, so here we just go ahead and pick x equals -4, which is completely random. You can pick whatever you like. Okay, and we plug it into our original inequality. So that means -4. I don't know why I put 4. -4 plus 3. -4 minus 2 is less than 0. Okay, so -4 plus 3 is -1. -4 minus 2 is -6. Is less than 0. So you get 6 is less than 0, which is false. Okay, so as soon as it's false, we already know that this is not a solution set, or not part of our solution set. So you can go ahead and draw a line through it. Not part of the solution set. Okay. And you do the same thing for the interval of -3 and 2. Whenever possible, I'll pick x equals 0 just because it's easy. And this is the one where you can pick x equals 0. And again, strictly random. You can pick whatever you like in that interval. Okay, so we plug it into our original. So you have 0 plus 3 times 0 minus 2 is less than 0. So that gives us 3 times -2 is less than 0. And really, you don't even have to multiply. As soon as you see a positive and a negative will give you a negative, you already know this is going to be a negative number. Is less than 0, which is true. So this interval is part of your solution set. Okay. So now you're going to do the same thing for the interval 2 to infinity. I'll just pick x equals 3, again, completely random. Pick whichever number in that interval you like. And plug it into your original inequality. So you have 3 plus 3 times 3 minus 2 is less than 0, which is 6 times 1 is less than 0. So 6 is less than 0 is false. So you can go ahead and draw a line through it. And you know it's not part. Let me separate that a little bit. Of the solution set. Okay, so out of all 3 of those intervals, only one of them actually came out to be true. Okay, so we go for our 4th step, which you don't have to graph it, but to kind of give it a visual. So from -3 and 2, and since we have a less than, we're going to use parentheses. So between -3 and 2, any value in there would be true for your original inequality. Okay, so that means our solution set is -3 to 2. And of course, parentheses. Oh, bring that up some. Since less than is used. Okay. Now, if that would have been less than or equal to, we'd use brackets. All right. So any questions on that one? All right. I'll leave that up for a few seconds. Alright, so let's say for our next example, if you wanted to solve x squared plus 4x is greater than or equal to 5. Okay, so here the first thing we want to do is we want to put it in the form we want to be able to solve it in. Put into ax squared plus bx plus c is greater than or equal to 0 form. Okay, so we're going to go ahead and rewrite it just by subtracting 5 from both sides. So we have x squared, I'm about to say plus bx, plus 4x minus 5 is greater than or equal to 0. Okay, so now we're going to go ahead and have our first step, which means we're going to find our critical numbers, which means we have to solve in standard form. Which means we're going to know where x squared plus 4x minus 5 is equal to 0. Okay, so since there's nothing in front of the x squared, we can try the original ways. Find two numbers that multiply to equal -5, and those same two numbers add to equal your b, which is 4. Okay, so for this one, you have 5 and -1. Looks like it'll work. 5 and -1. So that means you can rewrite this as x plus 5 times x minus 1 equals 0. Which gives us x plus 5 equals 0, or x minus 1 can equal 0. All right, so if we subtract 5 from both sides here, we have x equals -5, or if we add 1 to both sides here, x can equal 1. All right, so those are our critical points. All right, so now we're going to do our second and third step. Remember, your second step, you're just going to put your critical numbers on a number line. So we have -5 and 1. Okay, those are critical numbers, so we know we're not going to actually use them, so we draw a little dotted line to remind us not to use those. And this interval is from negative infinity to negative 5. And here it's from negative 5 to 1. And here is from 1 to positive infinity. All right, so now we pick our test values. Okay. So this interval, I'll pick x equals negative 6. Again, completely random. If you want to pick a different number, you're more than welcome. All right. Now remember, you can use that, or you can also use x plus 5 times x minus 1 is greater than or equal to 0. A lot of times it's easier to use the factored version of it, just because when you plug in your value, you can tell what's positive, what's negative, without having to go through all of that. Oh, let me clean that up just a hair. Here we go. All right, so if we plug that in, if we have negative 6 plus 5 times negative 6 minus 1 is greater than or equal to 0, you have negative 1 times negative 7 is greater than or equal to 0, or 7 is greater than or equal to 0, which is true. Okay. So if it's true, that means this is part of our solution set. Okay. So we keep that one. Okay. So between negative 5 and 1, again, whenever possible, pick x equals 0. It's just easier. You won't always be able to pick x equals 0, but when you can, it helps. Pick x equals 0, so that gives us 0 plus 5 times 0 minus 1 is greater than or equal to 0. Bring that up a little bit. Okay, which gives us 5 times negative 1 is greater than or equal to 0, or negative 5 is greater than or equal to 0, which is false. Okay, so if it's false, I usually draw a quick line through it, so it's not part of the solution. Okay. Then we go from 1 to infinity. I'll just pick x equals 2. And plug it in, see what we get. So we have 2 plus 5 times 2 minus 1 is greater than or equal to 0. So you have 7 times 1 is greater than or equal to 0. So that gives you 7 is greater than or equal to 0, which is true. Okay, so if it's true, that means this is, let me separate this a little bit, part of our solution set. All right, so if we were to graph our solution set, yeah, I guess you can put it in the fourth step. If you put in your critical points of negative 5 and 1, from negative infinity to negative 5 is in our solution set, so everything here, and from 1 to infinity is in our solution set. So everything here. And we're using the brackets because we have greater than or equal to. So whenever you have that equal to underneath, you're going to use brackets. So your solution interval is from negative infinity to negative 5. again using brackets, or from 1 to positive infinity. Oops, sorry about that. All right, so any questions on that one? Okay, I'll leave that up there for a few seconds. Right. Oh, getting ready to shut off. Okay, so what if we wanted to solve 2x squared plus 4x plus 9 is less than 0, and write the solution as an interval notation. Which is what we've been doing anyway, but it's actually in the directions.